we're going to take a look at a couple transformations for today. So the first transformation in blue is going to be looking at an absolute value function. And so here's the parent function for absolute value, as you saw maybe in the last video. Now, how does this transform, or how does this move? Shifting up, down, left, right. And then what about the vertical stretch, shrink, or horizontal stretch or shrink? So let's deal with the outside of the function first. Our letter K, represented in our formula, this represents up and down. So this plus 3 means that I'm going to pick my origin. My origin is going to go up 3. 1, 2, 3. And then this minus 4, this x minus 4 actually means we go to the right. So remember, it's the opposite of what we would think. So up 3, 1, 2, 3, and to the right 4. 1, 2, 3, 4. This is now my new origin. It's still going to be a V shape. So we know it's going to kind of go up and to the right and up and to the left. We know it's going to go up because there's no negative out in front. If there were a negative here, it would go down. Now this 2, for absolute value at least, this kind of acts as our slope. So this 2 is a vertical stretch, meaning if I had a big lump of Play-Doh and I stretch this vertically, what's going to happen is this parent function is going to get a little bit skinnier because we are stretching it. We're multiplying it by this factor of 2. So this number 2 here, we're going to go up to right 1. So with absolute value, we can kind of look at that as being our slope. You can't do that with other functions. But because absolute value is this V shape, we also know it's going to go up to left 1, up to left 1. So do you see how it's starting to stretch vertically? This parent function is now being stretched. It's closing a little bit. And so now I would just connect these dots as best as I could. So this is f of x. On the flip side, let's go ahead and take a look at a quadratic. So over here in purple, we're going to have a quadratic function, and I'd like to show you what the parent function of that is. I'll take away the parent function of absolute value here, but I'll leave up our f of x. So parent function of a quadratic, we still have a point here at the origin. We have 1, 1, negative 1, 1. We have 2, 4, and then negative 2, 4. So remember, the parent function is symmetrical about the y-axis. Now, it's not a V-shaped graph like this one. We want to kind of round this out as best we can. So it's more of a U-shaped graph. And so this is the parent function. There's your dotted line for you. So there's the parent function of y equals x squared. Now, in this case, g of x, we have some transformations going on here. Some are similar, some are different. We don't have any vertical stretches or shrinks or any horizontal stretches or shrinks in this one. But again, same process. Let's start with our shifting up and down, and then our shifting left and right. So this minus 4 means that we're going to start from our origin and go down 4. Every single point is going to do this. So we're going to go down 4. 1, 2, 3, 4. And then from here, we also are going to go, let's see, x plus 1, think opposite. So x plus 1, that means I'm going to go left 1. And the reason is technically in the formula, this is saying x minus this negative 1. That's why we're going left 1, because when we have a minus and a negative together, that makes a positive. So we're going to go down 4, left 1. So down 4, 1, 2, 3, 4, and left 1. So here's my new vertex. So from here, you would think it's going to be this U-shaped graph. We just don't know if it's stretch or shrink. However, this negative on the outside, that is showing us that we're going to reflect over the x-axis. So there's still no stretch or shrink, but because we're reflecting over the x-axis, we know this is, instead of being a U-shape, it's going to be an N shape. It's going to open down. Now the points are still going to be the same, so this is where knowing your parent function helps. So from the parent function, we went up 1, right 1, up 1, left 1. So because it's opening down, we're going to go down 1, right 1, and down 1, left 1. In the same way, we went to the right 2 and up 4, so 2 comma 4, because 2 squared is 4. Negative 2 squared is also 4. If we were to plot 3 and negative 3, we would be at 9, because 3 squared is 9, and negative 3 squared is also 9. So from the origin, we're going to go to the right 2 and down 4. 1, 2, 3, 4. And then left 2, down 4. 1, 2, 3, 4. And again, it's not a V-shaped graph. It is a U-shaped graph, or in this case, an N-shaped graph. So try to round that out as best as you can. So this is just a couple examples of some of the transformations that we're going to see that you saw in Algebra 1 and Algebra 2. So hopefully it'll get a little bit easier and we'll have more practice in class.